Good day, everyone. Today, we are going to look at a beautiful geometry puzzle that relies on a classic right triangle, but with a clever twist. Imagine a right-angled triangle, ABC, where the right angle is at vertex A. The side lengths of this triangle follow the familiar 3:4:5 ratio, and we are given that its shorter leg, AB, has a length of exactly 15 units. Because the legs must be in a 3:4 ratio, a quick calculation reveals that the longer leg, AC, is 20 units, and the hypotenuse, BC, scales perfectly to 25 units. Now, let's introduce a new point to this setup. We place a point, P, directly on the hypotenuse BC in such a way that the segment BP is exactly equal in length to our shorter leg, AB. Our ultimate goal for today's challenge is to determine the exact area of the resulting smaller triangle, ACP. To solve this elegantly without diving into complex trigonometry, we can look at the geometric relationship between the shapes. Since point P lies on the hypotenuse, it divides the total length of BC into two distinct segments. We know the total length of BC is 25 units, and we are given that BP is equal to AB, which is 15 units. By simple subtraction, the remaining segment PC must be exactly 10 units long. Now, if you look closely at the original triangle ABC and our target triangle ACP, you will notice they both share the exact same peak at vertex A. This means both triangles share the same perpendicular altitude drawn from it to the baseline BC. When triangles share an altitude, the ratio of their areas is strictly determined by the ratio of their bases. The total area of our large right triangle is easy to find, half of the base times the height, or half of 15 times 20, which gives us 150 square units. Because the base of our smaller triangle, PC, is 10 units out of the total 25-unit hypotenuse, it occupies exactly 2/5 of the entire base. Therefore, the area of triangle ACP is simply 2/5 of the total area of 150, giving us a final, clean answer of exactly 60 square units. Thank you, and I hope your students enjoy this elegant chase.